For the vertical asymptote, just where the bottom equals 0.
Oh, then, oh, yes, that'd be x equals -4. Just
Good,
x equals -4.
good, good. Yep. And then how about the horizontal asymptote?
Y equals 2.
Equals 2. That's good. So there's either one or the other. Like you don't
So there's
have
no,
both a
so in
horizontal.
this case, there's no slant.
Yeah, not applicable or something.
Yeah, I
What you're
think
looking
up there it
for,
just say like some items may not apply.
right? X-intercepts is setting the numerator equal to 0. Can you give me the x-intercept, please?
X-intercepts would be that equals 0 to negative -3/2, comma 0.
Okay, very good.
And then the y-intercept would be 3/4, so 0, 3/4.
Okay. All right. So domain might be easier to look at the graph. Yeah, I don't know. We should add the whole into the graph too. So it might be easier to do domain and range from the graph. Not sure here, but you said okay, there's a -4, and then there's one at 2. We got to draw those in. And then 1 1 is a whole. Draw that in. So that might help with domain and range. Give those a try, please.
All right, I got the domain from negative. Wait, actually, okay, let's see. All right, I got the domain from -infinity to -4, not including -4, union -4 to 1, union 1 to +infinity.
Okay, that works.
And then range, I put -infinity to 1, and then 1 to 2, 1, 2, and then 2, infinity.
That's it. Good job. Any questions on that?
Yeah, no, I don't have any questions with that.
All right, perfect. All right, so number 2, one of the things you'll start with with this one here, you want to notice right away that the degree of the top is bigger than the bottom. That means there's a slant asymptote. That's kind of the big thing. Is that something you guys talked about in class?
Yeah, kind of, yeah.
Okay. That's important. It's like what I've heard, and I do kind of like this. It's top heavy, top heavy. Okay. So the top one is sum of cubes, and could be, while since you've done that, you gotta, remember that formula there. I guess I'll write it at the top so you've got it in your notes. A cubed plus B cubed is A plus B, A squared minus AB plus B squared. And then on the bottom here comes X plus 1, X plus 3. So you got to be able to factor. That's why you spent so much time doing that in the last section.
Find it. Oh, yeah, I think I remember this now. Mm, um, couldn't you still factor this further?
You can never, never, never factor this next part. It always, if you recall, it ended up having complex roots. You did that in the last test. So I mean, like the answers, well, yeah, you can factor, they're just not real roots. They're
Got
complex
it.
roots. But the big thing here is the factors that cancel. And you
Which
get
means
x
there's a
equals,
hole at like, -3
yeah.
comma
So now you can come up with that hole.
-3 minus 3 times plus 1. I got -45.
I got just negative 27 over 2. The negative 9, or the negative 3 squared is 9. Negative 3 times negative 3 is 9, plus another 9.
9. Oh yeah, I think I missed that part. I multiplied this fraction. So yeah, then you would get 27 over -2.
So it's negative 13.5, we'll say. Which, not great, but that's what it is. So when you go down to that table, you can start filling in. You can fill in that the hole there. It's at -3, negative 13.5.
Good. So in this case, it would be, yeah. So then for the horizontal asymptote, wouldn't it not be 1 because the
There's
numerator
none.
degree is greater than the denominator, so there wouldn't be.
Right. So this is where you got to use either polynomial or synthetic division. I would use synthetic division because it's faster than long division.
Uh, yeah, that seems that's what we did in class.
And so sometimes there's like, well, what is it? It's this part right here. It's not the remainder. So it's y equals x minus 4.
That, then,
Okay. And so yeah, that could be its own sort of conversation. The x-intercepts here,
I don't think
um,
there is one
yeah,
because
there's none. And there's not always, like sometimes, And you can actually see graphically, if you look at the graph, it doesn't cross the x-axis. So there are none. Right? When you it doesn't ever cross, but these almost always have a y-intercept. Y-intercept is putting 0 in for x. You can actually see that from the graph right there. 0, 9. And then -3, -13.5. All right. So with that, could you come up with the domain and the range for us, like you did in the previous problem?
Yeah. Mhm.
Another thing here, Karthik, I guess I should mention at some point is the graph of the slant asymptote. Hopefully you're comfortable with that. Actually, they've got the wrong index, but something like that. You'll get that in there as well.
Yeah. All right, I got it. Negative infinity to -3 union -3 to -1 union -1 to infinity for the domain.
Okay, that's correct.
Then range is negative infinity to -27/2, and then
Okay.
union, or like -13.5 union 2.21 to infinity.
Oh, so does your teacher want to use the calculator for that and not the?
Yeah,
Okay, I was
you
wondering
don't have
like
to use a
why.
calculator just to calculate the
Yeah,
minimum
I mean, I thought you
maximum.
could get reasonably close here and just call it two, but yeah. Okay. Yeah, good. Good on that. Right. Very good. Definitely got an understanding of that. Speed as always is important here by your teacher. It's a lot on you. Whenever you're ready, if you want to send over a couple more problems for us to look at, or I'm happy to go find some to make them up for you.
All right, so here we pull up the other. All right, here are some. I want to go over.
Thanks for putting that in the chat. So it looks like just more of the same. All right, let's take a look at number 5. Um, all right, so one of the things I would recommend doing here when you start thinking about how to factor this is -1 comes out, so it's really x squared minus 9 up top. And then that you'll see, okay, that factors into difference of squares, x minus 3x plus 3. So really, really super, super important that you get it into factored form.
Got it.
Okay, so let's see what, if anything, on this list you can tell me, the
Uh,
usual stuff here.
so the
Anything
vertical
stand out to you?
asymptote is x equals 5.
Good.
The horizontal one, no, the numerator is, I don't know.
Yeah, it's top heavy, so this does not have a horizontal asymptote. So you could do the slant. Be very careful with how you do this. You're actually going back to the original unfactored form, but there's a 0x there to consider,
Yeah,
right? It's really minus x squared plus 0x plus 9.
yeah. I was doing this a little bit earlier. It was probably I think I missed the 0 there.
Then
I just went directly from that to that. So yeah, yeah. Okay,
so
so
it's
then,
this part that you care about.
so it's negative x minus 5.
Minus x minus 5. Y equals minus x minus 5.
Minus x minus,
All right. And then are there any holes?
no, they're not equals.
Yep. So x-intercept, it can have more than one. In this case, it does.
X-intercept at -3, 0 and 3,
Okay.
and then y-intercept at
So that, so
negative,
that, yeah, that's where it's better to go back to the original form.
That's negative 9/5.
Yes.
Let's see.
Domain. Um, so let's go look at the graph and add in some of the things. Is there a reason your teacher gave you the graph but didn't like, are you supposed to add in this stuff? Was this just to help? Like,
Yeah,
do you,
that was you're supposed to like graph in the vertical asymptote, or like if there's a hole, like just draw like a open circle at that point.
okay.
So in this case, it'd just be the slant asymptote and the vertical asymptote, so far.
Um, so like, yeah, I mean, x equals 5, you got one there. You got the x-intercepts there and there, y-intercept there, and then that slant, minus x minus 5, 2, 4, so somewhere there. Does she want you to use a ruler? Or can you kind of
Um,
hand draw them?
Probably. There you go. Now we have everything. On. So the domain would be negative infinity, 5, 5, 5, infinity.
No holes this time, so the domain and range is actually a little bit easier. It's split by the vertical
Yeah,
and kind of the you got to find these 2 points, which I know is a lot of
yeah,
work.
because it doesn't go all the way to the
Yeah. Yeah.
there. So let me plug it in. All right, I got negative infinity to 5 union 5 to infinity as and then for the range I got negative infinity to 18 union negative 2 to infinity.
Okay. All right. Let's look at the next one. Okay. So how would you factor the top?
You
What's the
could
first thing you
take
see?
out the x.
Yeah, and then you get 4x squared minus 9. On the bottom, we'll do the same thing. It becomes 4x plus 3. The top is difference of squares, even though maybe it doesn't quite look like it. Could you tell me
So
what that becomes?
uh, would become x times x
You-
minus 3 x plus 3.
Well, that only gets you the x. You have to get the 4x.
Oh
So
yes, you have to put 4x minus 3 4x plus
nope,
3.
nope, nope. And that's the mistake. See, that the teacher wants you that so that it cancels out with this. It's 2x squared.
Oh right, because when you square it you get.
And it's easy to do that because then when you said 4x plus 4x minus, you end up factor canceling with something on the bottom, which is completely wrong. Oh, you know what? Yeah, sorry. Um, so just be very, very careful on that.
And then I guess the x's could cancel out.
They do. So there is a hole there. There's a hole at x equals 0.
So 0. I get to put. So you plug in 0 for all the x's, you would get
That's right.
0. So 0 comma 0 is the
Uh,
coordinate of
I,
the hole.
I disagree. I disagree. You get 0 in all the places where there's an x, but there's a 3, a minus 3, and a so it's
Wouldn't you plug it into the original equation?
you always plug it. No, you always put it into the reduced form.
No, so
And
then in this
we've
case,
been doing that. So don't think there's an exception here because there isn't.
you could plug in 0 for the x's, you would get so it's negative 9, negative 9 over 3.
Which reduces to negative 3. So you always use the reduced form when stuff cancels.
All
If
right.
stuff doesn't cancel, you can use either form, but um, which is kind of true. There's that. I mean, I'm not giving you the full information, but yeah, that's what we got there. All right. So now let's see if we can fill in some of these other things. Vertical
So
asymptote
that'd be
question.
negative 3/4 because
Yes.
you're
X equals negative 3/4. Yep.
horizontal.
Horizontal asymptote. There is
Not
none.
heavy, so there's none.
No, unfortunately, actually, no, I take that back. So you could, depends how you want to do it here. You can use synthetic division. Uh, it's just a little bit more awkward. It's negative 4/3. Wait, no, negative 3/4. Sorry, struggling here a little bit. Yeah, so it's -3/4 in the box. You can use you could use the 2x plus 3, 2x minus 3, but it's really this uh multiplied out form. So that's 4, 0, -9. That works out. It works out okay like that.
Got
You actually don't even care about this. Like, don't focus on the remainder because it doesn't matter. This is what you need for the slant.
got it. So it's y equals 4x minus 3.
Yep.
X-intercepts if you
So you're gonna set the numerator equal to 0. So there's two x-intercepts this time. There could be two, there could be
4x
one, there could be
cubed
none, there could be three.
minus x equals 0. Take out the x straight to x minus 9. Cube root, cube root. Um, this is fine.
You have the x-intercepts for me?
No.
You're
Can I
just setting
retry
the
it?
2x
Okay.
plus 3 equal to 0 and 2x minus 3 equal to 0. The factored form.
0 equals 2x. 0 equals 2x. Minus 3. 3 minus 3 minus 3 equals 2x. All right, so the x equals 3 halves and x equals negative 3 halves.
The 3/2, comma 0, -3/2, comma 0. How about the y-intercept?
3
This one's a little bit deceptive because you'll find that if you do it, you'll get the same coordinates as the whole. There can't be both a whole and y-intercept at the same place. So this is none.
got it.
You got a really good teacher, but very deceptive problems. Like these are not the best ones to start learning with. I mean, so um, the domain and range is actually much easier this time because there's no gap between them. The graphs or the range part. You don't have to find them in the max. So the domain, you'll have to work on the domain, but the range is minus infinity to infinity on this one. But the domain you'll have to work out a little bit more.
Domain minus infinity to negative 3/4 union 3/4 to the positive 3. Okay, yeah. I got it. Negative infinity to negative 3/4, and then negative 3/4 to infinity.
No, you're in a
Oh
hole.
yeah, there's the hole. Yeah, I forgot about the hole.
Yeah.
Uh, yeah,
That's what people say when they
fix
walk into a
that.
hole. They say, I forgot about it.
So then it goes from so negative 3/4 to negative to 0, union 0 to positive infinity. All right. Let me pull up the next one. Okay, so this is the next one.
All right. Um, we are getting close to being out of time, so let me just see if I can maybe talk you through.
I
We
think the
could
one
probably
that I
do.
had the most questions on was the first one. So you go, I think that one, the seven, number seven. That
I
was
mean,
what I
so
was stuck on.
the issue with seven is the challenge of factoring it. So it ends up being x squared minus 25 x minus 3 over x minus 5 x plus 2, and then you get x minus 5 x plus 5 over x times x minus 3 over x minus 5 x plus 2. And you might consider checking my signs on that. Let me just foil that real quick. Yeah, it looks good. Okay, so that actually is fine. So that's kind of where if you can factor it, then all of a sudden you can do the rest. You can see there's a hole at 5. You can get the x-intercepts, the vertical asymptote, things like that. All right, we do have to stop here for today.